Okay, so if you want to remove the heat from something, or move heat, one place will get hotter, another place will get colder, whatever. Back in the day, your option was ice. Cut it out, try to store it, lose a lot of it. But that was an option. Even to this day, we still do that with coolers and so forth. Just keep adding ice. And ice, depending on the devil in the details, is around 130 watt hours per kilogram. But you had to keep adding ice. So we invented this in a refrigerator. It's a fairly small box, and it has insulation, but it allows you to, instead of continuing to be putting more and more ice into it to keep it cold on the inside, you supply electricity, and a device pumps the heat out of it. So the inside stays cool, and that heat gets removed and put somewhere else. A regular house fridge, like the one that I have here, is just under 700 watts of power when it runs. It's not running all the time, but when it runs, that's what it consumes. Then throughout the year, that's the rate of 22 kilowatt hours. Which is fine for a fridge for a house, but maybe you don't need that much space, and so you want something smaller. Well, they do make powered coolers you can take, and this is a little Peltier module. This is a solid-state device, a little, you see that white square on the top. You supply a current, it pumps heat, so one side gets cold, the other side gets hot, and the bottom you see a heat sink and a fan to remove some of that heat. That's a cold plate. Now you can use those to cool a box, and people do that. They're solid-state devices, straightforward and fairly convenient, super small, super lightweight, for about 75, 80 watts of cooling, electrical power supplied, you will get about 75 to 80 watts of thermal cooling, or around 250-ish BTU if you prefer your BTU measurement. Now, one advantage is, though, you'll notice your home fridge doesn't use Peltier modules, it uses the refrigeration cycle. So there are people who make, like this is a Dometic. This uses a refrigeration cycle, so there's a compressor and evaporator and condenser and all that stuff put in there. And this allows you to have that cooler, so you're not continuing to add ice, add ice, add ice. But the advantage here is that the coolers out there that are powered that use the Peltier modules, the ones that like this Dometic, to get that same, say, roughly 250 BTUs of cooling, roughly, say, 75, 80 watts of thermal cooling, only costs you about 45 to 50 watts of electrical power. That's because the heat pump system, compressor, evaporator, condenser, is more energy efficient at moving heat from one place to another compared to a Peltier module. That's why our home fridges use them. Maybe you don't want to cool just a small box, a fridge, a freezer, things like that. You want to cool a small space, a small 100, 150 square foot small room, something like that. So there's a window air conditioner, and here's the specs for it. It's about 5,000 BTUs. The energy efficiency ratio is now up to an 11, but it's consuming 460 watts of power. It's up to about 40 pounds. So it's more efficient, but bigger and heavier. The Dometic is about somewhere between 5 and 6 energy efficiency ratio, depending upon the conditions and details. This one is an 11, so it's much more efficient, but it's about 460 watts of power and about 40 pounds. So maybe you don't need something that big or that much cooling. So here's a example of something smaller. It's a air conditioner. It's a refrigeration cycle, compressor, condenser, evaporator, all that kind of stuff. It's efficient. So where the Dometic, we were seeing around a SEER energy efficiency ratio of around, say, 5 or 6, depending on the conditions. This is about 9. We got the first generation on the left, which was about a 9, and the second generation on the right, which is an efficiency of about 9.3. The first generation on the left was about 13 pounds, and the version on the right is about 16.5. Previous model on the left was about 1,100 BTUs. The new version, Mark II, on the right is about 2,300 BTUs. And there I show a link to the video where I got this picture from. He goes into a lot more detail about the operations and experiments he runs, so I recommend going there to get that in more detail. But the interesting thing there is that now you have a personal cooling device that can be targeted at a person or a very small space. These aren't, of course, at 1,100 BTUs or 2,300 BTUs. You're not as much as 5,000 BTUs, of course, but you're much smaller, and that could be a benefit. When it comes to comparison to, say, the ice for cooling, ice at about 130 watt hours per kilogram, once you start getting the multiplying effects of heat pumps, even at the Dometic, at around 8 or 9 kilograms, you're better to have batteries and a heat pump than just bags of ice, from purely how much cooling you can get per pound of what you're carrying. The Zero Breeze is, like I said, better. It's like 9 instead of the Dometic's, 5 or 6. Here we have, if you're going to go in the other direction, you want more efficiency or you need more cooling, this is a mini split. And the mini split goes all the way up to 12,000 BTUs here. The energy efficiency ratio is all the way up to 22, but it's like a 100-pound unit, so it's much bigger. I think all of these have a role to play in depending on your specific application. The Peltier modules are the smallest and lightest, but their energy efficiency is the worst. Ice, it can be convenient and low-tech and reliable, non-toxic, easy, all that kind of stuff, but pound per cooling, the amount of joules of cooling or BTUs, watt hours, however you want to measure it, Once you start getting above, 8 or 9 kilograms, which is, say, 16, 17 pounds, once you start getting up in that range, you're actually going to have more cooling available per pound of device you carry by bringing a battery and a cooler, like a powered heat pump cycle. And that's with the SEER of a 5 or a 6. By the time you get to the SEER of the 9 at the Zero Breeze, it's even better. Um, but they all have a role to play because you can't always fit 100 pounds. You don't want to carry that. Maybe you only want to carry the 16 pounds, and maybe that's good enough because it's just cooling. It's a camping trip or something like that. You're just cooling, blow the cold air right on me. I don't care about the room or everyone else. Um, so, which is the best fit for that person, I think, is a big important thing, and you're going to have to choose what best fits your application.